Now we are asked to draw the shear force and the bending moment diagram for this question here. So what do you do first in this case? First things first, as usual, whenever you're asked to draw the shear force and bending moment diagram of any support or a beam, your first task to get a reaction. In this question here, there is no A and B. There's not A and B. So put A and B here. So I'll call here point A, call here B. Here becomes what there C and what and D. Your first task to label them. This is A, this is B. Then it gives you C and what there and D. That's the first priority. Your next task is that if you observe that this one here is a kind of support called a pin support. This one is called what there a roller support. So I have to convert them back to what forces. So drawing first part now, I will draw the FBD. What's FBD there? Free body diagram. All right. For me, I'll have this one this way, this one this way. This one here gives you two reactions. So one being vertical, the other horizontal, right? This one here gives you just one vertical here, Abi. So if I call your point A, this one means what? RAX. This gives you what? RAY. Very good. This one here gives you what there? RBY. Why is it Y? Because it's vertical. Right? This one is X as because it's horizontal. So this is my point. What there? Point B. They call back your load. I have a load here. This is what? 10 kilonewton. This man here gives you 10 kilonewton. All right, we call it C, call it D. We said distance from here to here, here to here, and here to here are 2 meters, 2 meters, 2 meters each. All right, I have this one here. So what's the first task now? My first task is to get the value of RAX, RAY, and what the RBY. How do you do that? Using the condition of what? Equilibrium. Are we? So using the condition of equilibrium, using the conditions of equilibrium, what do we know? You know there are three conditions, right? We have the summation of H equal to 0, Abi. Summation of what? V equal to 0, and moment at a point is what? Also 0, right? So these are the three conditions. So let's start the first one. Summation of horizontal component. All right, that's summation H, Abi. Summation of H equal to what there? 0. What am I considering? Okay. F of X. Abi? Is that Fy? F of X. That is for you. Okay. In essence, I can say summation F of X, the same language. F of Y, depending on your author and your lecturer. Right? So let's use F of X. If that was your lecturer used. So this F of X is equal to 0. I'm considering right to be what? Positive and left to what? Negative. How good? Now check this system here. Which force in quote is acting in this direction from here? Which force is lying down in this part in this diagram here? Just one. That's what REX. So now this ones here are acting vertically. Horizontal is REX. So summation of F of X is just one. That's REX. So I have RAX. Please, that's all Abi. Then equal to what? 0. So this automatically means that RAX has no value. That's 0. It's done. What's next step there? Get what? F of X, Abi. Yes, sorry. F of Y. Next task. F of Y. Now summation. Okay. All right. Y. First. Moment. Anyhow you want to do it. But it's quite okay. You start with the order of arrangement. Age. Anyhow, you say okay. I say okay. If anyhow you want to do it, depends. Anyhow you want to do it. Right? Just know it. Summation of what? Vertical component For this one here, I have summation of what? F of y equal to what there? 0. I'm considering to sabi. All force to be what? Positive, down to be what? Negative. So any force going upwards is so positive, downwards is what there? Negative. In this case here, let me check this forces, this system here. Which force are acting in these two forms? There are many there. 1, 2, 3, 4. They're just 4. This is 1, 2, 3, 4. Now put them here together. This one going up, positive abi. That gives you RAY positive plus this one goes up abi plus what there? RBY. Observe this one is going downwards and down is what there? Negative. Gives you minus what there? 10 minus what again? Minus 10 equal to what? 0. Summation of x gives you everything here. Equal to is this and your 0 remain this. Now combine this together. I'll have RAY plus what there? RBY minus what? 20. True? Equal to what there? 0. I'll take this 20 to the what there? Other side. This gives you RAY plus RBY equal to what there? 20 what? Kilonewton. Call this man equation 1. How good? Now, I've taken the first condition. Second, what's next there? Taking moment. All right. At what point there? At point A. Why point A? Because point A has what? Two reaction. So always take moment at where you have what the two reaction. So taking moment at point what? A. That gives you summation of M A Abi, right? 0 Abi. What are you considering here? Here is left and right. Here is up and down. Here is what the clockwise and what? And anti-clockwise. That gives you this one positive, this one negative, right? So clockwise direction gives you positive, anti-clockwise gives you what the negative. So let's get the value of summation of A. Before I proceed, copy down before I proceed. Just understand the concept. Any diagram are given, get the reaction. From reaction, get RAX, RAY, and then RBY. But to get there, to get those values, you need to apply condition of equilibrium, and which are three: f of x, f of y, and moment. So let's take moment. Let's work on moment. How good? By the word shear force and moment diagram, it means shear force is separate. This one too here is what is separate, right? So from here I'll take this part off because I can't clean diagram. Okay, if I clean diagram now, it will affect us because I want to use diagram to calculate for the moment. All right, or perhaps per se I can still take this one down because I've redrawn the image. So let's do this part first. Let's do this one. All right. Now at this point here, we said taking that at point A or B. So at this point A, we said here's the analysis I do give when it comes to moment. I have this point here. Let's assume that they are fighting. It is expected that this neighbor 1, 2, 3 will always want to check what's happening so that the war won't reach their place or for safety. You get? So they are fighting here. Now I'm saying this. Anywhere you take moment form is always 0. It means that this one and this one are there at 0. They are dead already because they are fighting war here. So they are all dead already. So these people are like, okay, what's happening here? Let's come and check. Now we said moment from physics is defined as force times distance. That's moment. Now we said this 1, 2, 3 will come to A to check that what kind of problem is happening. If this man comes to A, will he move this way or this way? Which is shortcut? Will you move this way, down here, or just this way? Which is easiest? Moving this way, Abby, is the easiest than moving this way down here. Like this is the easiest. So look for the easiest route to that point. This one want to move. Will it start moving like this or just like this? To move what? This way. Observe. Oh, this one has only one direction. Will it move like this or just like this? How? Like this, Abby? Because these are the easiest way for them to get to point A. That's case 1. Case 2 is that observe the direction. Is it a clockwise or an anti-clockwise? If you check it very well, this is a what? A clockwise, Abby. It follows the normal clock pattern, right? So now here's like that. We said moment at point A gives you what's the first force here? 10, Abby. That becomes 10 times what distance? Now observe from before this C want to come to this point. Here to here gives you what there? A 2. That gives you 2. Case 1 done. Plus into, let's go to D. For D, this moving to point A. Covering what, how many distance there? 4, right? And this is a what? A clockwise direction, right? That gives you 10 times what there? Times 4 plus into this last part, which is B, is come down to A. Moving what? In an anti-clockwise. That gives you negative what? What's the force there? RBY is the force. That gives you RBY times from here to here gives you what there? 6. Alright, I have 6. Being equal to what there? 0. Because I have equal to 0, 0. How good? Now from here now, we just multiply and get through. This gives you 20 plus 40. Now it's expected that I know that this times this gives you 6RB. Plus minus gives you minus. So I have minus what? 6RBY equal to 0. Take this young man here. That gives you a positive RB. Combine this, I have what there? 6RB. 60 equal to 6RBY. I want to get RBY. What do I do? Divide by what? By 6. Divide here by 6. Divide here by 6. This cancel this. So what's RB? RBY equal to what there? 10 kilo. Of course, because 6 here 1, 6 here 1, that gives you 10. So RBY, we have successfully gotten the value of RBY. We need to get what? We have gotten RX as 0, RBY as 10. Let's get what there? RAX. RAY. How? Put RBY into what? Equation 1 to get RAY. So copy down and let's proceed. Copy down and let's proceed. So I'll just recall from equation 1. So from here, recall from equation 1. So recall from equation what? What's equation 1 there? This one, Abby? This one here. That says what? RAY plus RBY equal to what? 20, right? This man gives you RAY plus what's RB? You just got the value as what? 10 here. That gives you 10 equal to what? 20. Take this one here. That gives you 10. So what's RAY? RAY is equal to 10 kilonewton. I'm done looking for my reactions. The first priority when it comes to shear force and bending moment, get your reaction first. All right. So proceed. Now I'll clean all the board now, and I'll only draw back this diagram alone and put the answers to these ones inside. That is RA is 10, RB is 10. Now is okay. No, we'll do that one. We'll do it very soon. But here's the idea. Observe that we have 10, 10. Add them, that gives you what? 20. Here's the idea. This beam, or let's say this beam, this is here. I had a weight of 20 kilonewton on this beam. For this beam to not fall, the load that must be down must have more power than it. Now this one gives you 10, this one gives you 10. So up is 20, down is 20. It is balanced. It won't deflect. Now because the beam deflection. slope equation, gradient equation. That was another thing entirely. So that's this for this one, by the way. So I'll clean the board and draw that back the diagram and the values we got, and then we'll look at the shear force calculation. All right. All right. I think I have this way. The value is here. It's 10 kilonewton. Another value is here. 10 kilonewton. All right. I have what I have here. RAY. That's of course 10 what? Kilonewton. Here I have the value of what? RBY. This one gives you also what? 10 kilonewton. Next task from here to here gives you 2 and 2. 2 meters, 2 meters, and then all right. Let's focus now on getting shear, the main purpose of the question, which is what the shear force calculation. All right, let's do shear force calculation. All right. Now, okay, you said here is A, here is B, here is C, and here is D. All right. How good. Now, observe very well. I want to get shear force calculation. What do you know? Now, listen. It's easy as identify the section in the diagram. I have A, C, D, and B, not A, B, C, D. Follow them the way you are seeing it. I'm seeing A first, before what there, before C, before what there, before D, and before what there, before B. Now listen. Please note something. Shear force always starts with 0, but does not end with 0. First priority noted. Now, outside that, how do you get what's it called? How do you get the value of A, C, B, and D? Now, here's a technique. Whenever you get a value for A, before you get C, repeat that value down first. We'll consider C. Whatever answer you have in C, repeat that value down first before you go there, before you get D. That's what we said in our previous classes. Now, here's like that. For A, now I'm moving. I can move in two form. If I'm moving this way, right, my right hand side this way, I'll consider up as positive, down as what? Negative. Moving from my left hand side, how good? If I'm moving this way, I want to move this way. Like this, I'll consider this first, this. That's left hand side, right? You can see my left hand side, right? So it means that my upper positive, down is negative. If I want to move this way, then I want to consider B first, before D, before C. I'll make up to what? Negative, down to what? Positive. How good? But we're all familiar with up being positive, down being negative. So I say, let's use what? The left hand side. So from the left hand side now, what's A? A is going upward, Abby. So and that's what? 10, Abby. For upward, is it negative or positive? That gives you what? I'll have 10 here. 10 what? Kilonewton. That's all for A. What is C? This is C, Abby. Observe, this is C. Alright, please listen. We said for A, this man going up. And for every up movement is what there? It's positive. For every question, Abby. For every up movement is what? Positive, Abby. So I have a positive value here. Now, so we consider the next part. Put the value you're having down here first, Abby. That gives you 10 first. Then for C is going down or up. Down, right? Down what, Abby? So that gives you what? Negative, Abby. 10. That gives you what? 0. Right? So please don't add kilonewton. Don't like that. 0 is 0. Don't add 0 kilonewton. Alright. That's for this one here. What next again? What do you observe? This one here, 0 down here first, Abby. For D, this is going what? Down, Abby. negative what? This one gives you negative 10. How good? Shear force start with a number and what? End with what? 0. That was it, right? Alright. For B, repeat this value down, minus 10, Abby. Then for D, sorry, for B, up or down? Up or down, right? That's positive what? Positive 10, right? They gives you what? 0. Are we good? Observe now. This D finally gives minus 10, Abby. This is the value here. For B, this B is going upward. I said up is what? Positive. That's plus 10. This one is this first. The B itself is positive 10, right? Together, you have what? 0. That's the concept. I said it starts with a number and always end with what? 0. I'm done with my shear force calculation. Let's do bending moment calculation. All right, let's do bending moment calculation. All right, what do I get here? So look up. Okay. What is it? Okay, yes. So for bending moment, it's still the same concept. Repeat what I have in here. I have A, I have what? I have C, I have D, and I have what there? I have B. That's the first task, case 1 done. For the case 2 now is that we said for shear force, I said note something. It starts with a number and end with 0. This one starts with 0 and always end with what? 0. That's case 1. Case 2, in this case here, for to get on that section, you will repeat what you have here first before you consider that section itself. This one, you're not repeating, you're just calculating, right? Now, at point A, please, we said anywhere the document from is what? Is 0. At point A is what? Is 0. That's 0 basically, right? Because I'm using left-hand side pattern. Left-hand side pattern. I am moving from the left-hand side. So if I'm moving on the left-hand side there, we assume that clockwise is what? Positive. Anti is what? Negative. Now listen, it's a two-way thing. If I'm doing right hand side, up with what? Negative. Down gives you what? Positive. But I'm using left hand side because we're familiar with the idea of up being positive, down being negative, clockwise positive, anti-negative. How good now? So for moving from left hand side this way, for this one too, if I'm moving this way, observe, if I'm moving this way, I have A here. I'm moving this way. Is there any force here? Nothing. So if I take at A is what? 0. If there was one force here now, if I take here at 0, that force will now come and see what is happening at A. So at A now, nothing is there. That's 0. That's 0 you're seeing here. How good? Now at C is still 0. But there's a force that can see what's happening here at C, which is what? Force A. How good? Now at C now is still 0. How good? But if I take one at C this way, there's one particular force. Go, I'm moving left hand side. This one can't see it at all. They can't see it. Okay, I'm moving left direction. So this is the only one I can see what's happening here. How good? So this one move this way now. That's a what? A what? A clockwise direction, Abi. That gives you RAY times what? Yet here it gives you 2. How good? That's plus into RAY times what? Times 2. Observe. Take a look at C. Now at A is 0. We're done with that. Since we have left A now, A is still alive now. At C now, I'm moving left hand side this way. If I take a look at C, C is 0. But this one here will come to A. Now moving this way means clockwise. Okay. Because any way take moment form is 0. Yes. And this is 0 here. Now at C now, take a look at C. What will happen there? Everything will be 0. Let's say, because I'm having every section here. I'm having every section. Many moments, it's all about moment at every section. Now at D, I'll take moment 2. That is still 0. But What's particular about it is that all the forces there should be going down to that point. At A, take note at A, that gives you 0, no problem. Take note at C, is still 0, but this one here is a force, it's not alive. I'm not here, I'm in C now. This one is not alive, it's no more there again, it's not alive now. If I'm fighting here, this one will want to check what's happening. It's moving this way now. Move gives you RAY times what? Yet here gives you 2. This is the only force that can see what is happening at T, because I'm moving from left hand side this way, right? So this gives you 0 is off, right? What's RAY? That's 10 times 2 gives you what? 20 kilonewton. No, gonna say drop this one here. No, that's for shear force concept. For this one, I've gotten 20 as my C. Which one there? This one here, Abby? Yes. To save space, that's why I just had to try it this way. And it's not enough to put that there. No, it's not a must. Just if you know what you're doing, just put the values and go. Right? Now, I'm just doing for teaching sake. At D, where's D? This is D, right? D, Abby. Take note at D is what? It's 0. But 1, 2 will come down there. How good? So this one move from here to here gives you what? 10 times what? Times 4, Abby? That gives you 10 times 4, perhaps. That gives you RAY times 4, first case, plus into this one move this way, Abby. That's what? Anti-clockwise. Observe. Negative direction, right? So this point is moving this way. And that's the what? In negative direction. That gives you minus what? Minus 10 times what? Yet here gives you, yet here gives you 2 now. From here to here is 2. Is 2. This man gives you 40 because RA is 10. Right? RA is 10, right? 10 times 4 gives 40, right? Plus minus gives you minus 20. This man gives you 20 kilonewton. What again left? B, Abby. So here's the thing. Manometer with 0 and must end with what? Let's see if this part end with 0. If I talk about that B, what do you expect? 1, 2, 3 will come down to what? To B. How good? Now RA to B gives you 10 times what? Times 6. So I have 10 times 6, first case close. This almost what? Anti-clockwise direction, Abby. That gives you negative 10 times what? Yet here gives you 4 plus into this man move this at same anti-clockwise, right? That gives you what? Negative what? Negative 10 times what? 2. Alright, I have this. Work on this. This gives you 60 minus 40 minus 20. What's the value here? This man 0. Because negative 40 minus 20 gives you negative 60. Plus minus 60 gives you 0. Yeah. Right? So I have this. So we're done. Let's not do diagram. Let's not draw diagram. So at least in exam, 5 minutes you're done with this. If you did it very well. Right. All right, let's get diagram. Are you done writing this one? All right, let me take it off and let's do diagram. No, it's UDL. Yes, kilometer. Yes, if like in terms of doing diagram, you put it there, right? No, UDL is kilometer per meter. I thought you said per meter, but kilometer meter is for you a very moment. Like this, Abby. You put the value meter, right? All right. So that's the only thing there can be a value. Zero is nothing, right? Zero is nothing. Zero is nothing. So know that very moment is 20 meter, right? Not per meter. Yes. 2020. Huh? How good? How good? All right. Let's do diagram, please. Diagram. The diagram for this, I have my force back. Sorry. Draw out my force back. Now listen, please. 10 kilonewton. 10 kilonewton. This point A. This B, C, and D. Here I have 2, 2, and 2. 2 meters, 2 meters, and then 2 meters. Alright, now listen. Before you draw a diagram, always try to reproduce out the inside diagram this way. When you are done with that, take them downwards this way. Take it down this way. Right? This part C, take it down this way. This part D, take it down this way. And of course, part B, take it down this way. How good? So I can just come here, just a random graph, right? So this is my point 0, point 0, yeah? Now listen, I'm doing my shear force because the shear force that comes first, right? Look up. I'm doing my shear force up. So this is positive side, negative side for my shear force. How good? For the very moment, I'll still draw on that origin down here. Now, in this case, now what do you observe? Observe that listen, if you check your shear force, let me check. What's the highest value that is there? Highest value that is there. Check highest value that is there. What's the highest value that is there? Highest value that is there. 10, Abby. So yes, I there. Now I'll just do a rough sketch. It's just a rough sketch. You're not using graph basically. At A, what's shear force at A? This is shear force diagram, please. At A, what's shear force? 10, Abby. What's it 10, Abby? Plus 10, Abby. I can just come and say, let me put it as 10. 10. What after at C? What's at C? What's at C? Shares at C? 0, right? 0 is here, somewhere here, right? So let me just aesthetic here. 0. What next again? What next? At what? At D is what? So let me just come here and see because minus is coming downward. Look up. Minus is going downward, right? So it's going down. So let me just call here minus 10, right? What next again? At B is what? 0. So minus 0 here. How good? Now here's the idea. We said when it comes to point load, for the shear force, connect them in a rectangular form. How good? Connect them in a what? Rectangular form. Observe this one now. This one will go this way. Observe, will go this way. Abi? This one come down this way. Abi? Come this way. How good? Take it down this way and then this way. That's all. Right? This one. I want to connect this one to this, but rectangular form. So take this way down to this place. I want to link up to this. I can't just go like this. No. I have to come down here and then take it this way. I want to move to this place. I can't move this way like this. No. It doesn't give a rectangular shape. I have to go this way and then take it this way. How good? Then I can now shade it. This positive region, negative region, and I can just come here and shade this man. You don't in your book. Don't show the value. Leave a space for the value. This one here, I'll shade this one too. All right. I have this. Let's draw what now? Bending what? Yeah, this one is in kilonewton, please. Kilonewton. I'm done with this. Let's do bending moment diagram in what? Kilonewton meter. I'll draw an origin here this way. 0, 0. Knowing fully well that the upper part is positive, down part is what? Negative, right? What do we do here first? We said at A. What's A? A is 0, right? A is 0. So this is 0 at A. 0. What's at C? At C is what? 20. So look up. C is 20. Something is coming here, somewhere here. C is 20. What's at C? Sorry, at D. That's also 20, right? Also 20. At what again now? At D is what? B is what? 0. Alright, I have 0 here. When it comes to the random what? With inclined line. Inclined. So this one this way. Just try to make it incline. Just this one I cannot incline because it just is straight from this way. Because I say level. Then incline down this way. Sorry. It's like a straight line or not a curved parabolic one. Alright, so this is my bending moment. This is a positive region, right? Just shade it, shade it, shade it, shade it, shade this one. Alright, shade this way. Alright. So this is how you draw a shear force and a bending moment diagram for this particular question. In the next class, we'll look at much more question as we proceed in the next class.
I just launched my website www.ganiabukari.com, as you can see in the screen. In this website, you can get close to 4 to 5 tutorial courses that are there. So we have different courses there. Also, the book I just launched also is in the website. You can visit our website and get the courses you want to watch. And also, the video you're watching recently, you can get more of these interesting videos in the website. So do well to visit the website and also register an account with my website. See you guys in the website, and make sure you buy a course from the website to support our journey of this academic platform. Thank you guys, and welcome to my channel. Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen. Alright guys, you can now join my channel membership to have access to exclusive videos of mine, which most people will not have access to. To get this link, this membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both. Right, so once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.